Hi guys, and welcome in this new tutorial of Blender and Geometry Nodes. My colleague asked me to export a Blender project in a CAD file, this time the DXF format. I tried to use the native add-on of Blender, but I found some limitation, so I decided to show you how to make a 2D projection system for 2D drawings, including these features: real-time projection and animation of any collection of meshes, switching between top, front, right, or all these projections, assignment of line styles through customizable styles collections, colors and thickness overrides, background addition with color and margin parameters, cut sections with offset parameter for each projection in portals mode, and 4 types of results: simple lines for export to CAD format like DXF, stylized lines for export in images and prints, real-time portals interacting with lighting for rendering, both portals and stylized lines. So let's get started. To show you a practical case for this purpose, I have this project here. I'm using a Blender 4.4.1, and the idea is to take this collection of meshes that I have in this collection called assets, and what we want is to project all these meshes on the X and Y plane to be able to set the top view and see the result of the 3 views: the top, the front, and the right, together or one of them. So we can start to go in the geometry node, going here in the plus button, general, and choosing the geometry node. We need a new mesh for this purpose, so I close the asset collection, select the collection, press Shift A to add a new mesh, and we can create a simple plane. So this can be called 2D projection. We can make a new setup for the geometry nodes, and we can call it 2D projection. We can enable the snap tool with this button, and first of all we need to take all the information of these collections and scale all the meshes to 0 on all the 3 axes. And to do this we can press N, add in the group input a new socket, and this is the sources, and the type is a collection, and we can select our assets. Now I can drag with the left button and select the collection info. We don't need to select separate children, and in this case we have only one instance in this output, and we can realize these instances to have the entire mesh with all the vertices we need. And what we can do is to set the position of all these vertices you are seeing in this moment, stretching all on the X and in detail in the value of 0 to have all the meshes on one single plane. I can show you this result, taking the position of all the single vertex of this mesh, separate these in the X, Y, and Z, using another combine X, Y, Z node, and linking this vector in this position. Linking what? Linking the Y, the Z component, leaving 0 in the X component. In this way, if I link the output of these realize instances inside this set position and press Shift Z, you can see all the meshes stretched on the value of 0 on the X-axis. Now we need to do the same for the Y-axis and the Z-axis. So I can take these nodes, press Shift Ctrl and D to duplicate and maintain the same connection with the output of these realized instances, and instead of linking the Y and the Z, I want to link the X and cut the Y connection. Now if I connect the output of this version with the Shift, Alt and click, you can see the stretching on these axes, and we can have the same for the Z component, pressing Shift, Ctrl and click. I will cut the Z information and I link the Y information, and if I press Shift, Alt and click, you can see all the meshes projected on the X and Y plane. I can use several reroute to better organize the connection of these nodes, like these. And now that we have the X information, we need to rotate this final geometry to be on the X and Y plane. So we can take this mesh and rotate 90 degrees in this direction, and then 90 degrees on these axes. So 90 degrees on the Y and 90 degrees on the Z axis. And to do this, we can use the transform geometry, link a rotation node, and specify, in this case, minus 90 degrees and minus 90 degrees on the z-axis. Indeed, if I link this geometry, I have this result. Why? Because if you set 0 and increase this value like this, you can see I want minus 90 degrees, and if I rotate like this the object, I need to set here minus 90 degrees, and voila, I have the right view. Now, to have the same for the other views, I need to take these nodes, Shift and Control. I need to link the front view, and if I press Control, Shift and click, you can see the rotation is wrong. So first of all, I set 0 and 0, and what I need is to take these rotation and have this result, so I need to set here minus 90 degrees, and that's it. The same for the Z. No, it doesn't matter, because the result of this set position is already on the X and Y plane, so we don't need to do anything. So now, because each of these projection has a different size in width and length, we need to move all these three views to have a common origin point to be able to offset these three views as we want. So we can choose, for example, the minimum point of all the original collection of assets as the origin. So to do this, we need to take the bounding box of the original collection of assets, so all these meshes like this. So we can take these, link and link in a reroute node, drag these in a bounding box. So in this way we can get the minimum and the maximum position of all the bounding box that describes this collection of assets. So the minimum point is here, as you can see from this axis. The minimum point in the 3D space is here, and the maximum point is here. So we need to take this position. This position is described by this vector here, and the idea is to take this projection, for example, calculate the bounding box. So in this way I would have a bounding box with 0 for the height, and this point for the minimum and this point for the maximum, and move all the objects and all the lines by this offset. So this offset is exactly the difference between the position of the minimum of the collection and the vector of the minimum of our 2D projection. As you can see, this vector is the sum of this vector and this vector. So to get this vector here for the offset, I need to subtract from this position this position. So what I have here is the minimum of the entire collection. What I need is to take the bounding box of the 2D projection. In this case, we are looking the result of the Y, but if I link with the Shift, Alt and click, this is the 2D projection from this perspective, rotated on the X and Y plane, and we need to do the same. So I have this position, and in this case the minimum of our 2D projection is this vector, and to offset the entire geometry from this point to this point, I need to take this vector here and subtract this position, and in this way I can have the difference vector, and I can move all these lines by this offset. So in this case we have this minimum, and I can take the minimum of the collection and subtract the minimum of our 2D projection, and next with this output I can take these and link another transform geometry, translating this transform geometry by this offset, this difference. And now if I link with the Shift, Alt and click, you can see this offset, but is wrong because I used, as you can see, the maximum of the collection and not the minimum. So I shifted this entire 2D projection on the maximum point. So in this case I used the wrong link here. I need to use the minimum and not the maximum, and voila. So in general, if you want to offset something from a point A to a point B, you only need to translate your object by the difference between B and A, so the destination and the source position, like this. We need to do the same for the Y result. So this is the 2D projection from this perspective, so the front view. And in this case, we need to do the same, so I can select this node, Shift D to duplicate. We can link this geometry here, this to the output, link the minimum in the first socket, and I also need in this case the duplication of the bounding box linking the result of the 2D projection, and link the minimum in the subtraction. And as you can see, we moved the 2D projection. The same for the 3D, for the top view. So I can select these three nodes, Shift D to duplicate, and I can link this output in the bounding box, create with the Shift and right drag a new reroute, and link these in the transform geometry. I can link this minimum here, and if I press Shift Alt and click, you can see the same result. In this case, you could avoid these three nodes because for the top view, the 2D projection is exactly aligned with the minimum of the collection of assets you are using in your geometry node setup. But if you want to have more control in the setup, you can leave these three configurations. Now I can take these three set position and press Ctrl H to collapse the node I don't use. The same for these two transform geometry, Ctrl H, so the beauty is better. We can collapse entirely this bounding box node with H, because we know the first output socket is the minimum and the second is the maximum. We can create some reroute, and this is the result of the projection on the Z axis. So we can select all these nodes, press Ctrl J, F2, projection on X/Y plane. Save the project. Now what we need is to be able to select what view we need. So if we want the top view, the front, the right view, or all together. And to do this, we can press F3 and add a menu switch, and we can select the node section and replace the first item with top, the second with front, right, and all. And if you want, you can add other views if you want to look this object and get a different 2D projection in addition. So in this case, we can use this menu switch to get what? An integer. So for the top, we can use the output to be able to use another index switch, and depending on the index of this output, we want a different geometry result in the viewport. And because we could use this menu switch more than one time inside our setup, Blender cannot allow you to duplicate this menu switch in the same level of setup in a geometry node modifier. So you need to press Ctrl G to make a group of only this node, and we can delete all these input in the group definition. So we can delete all these, and we can leave the menu linked and set the output. So I needed to change these because in my preparation file I used the right as the first and the top as the third, so like these. Perfect. And we can set 1, 2, and 3 for the indexes of this output. We can turn back with this button and rename this group in projection selection. Now we can link this menu in the group input node and link this output in an index switch. So in this way, the output, the index output of this node can manage the output of this index switch. And in this case, if I select this and go to the node, what we want is to have 4 inputs. Now, if I want to have the right, I need to link this on the 0 output, the front view on the 1 input, the top in this input here, and the join of all these were in the final number here in the index switch. So we need to link the output here and this join here, and this is the result. So now if I select the front, the right, the top, or all these together, we can have this result. But as you can see, we have a wrong 2D projection because what we need is to have the top here, the front here, and maybe the right 2D projection here to be able to see all of them. And to do this, we need to offset the 2D projection output of this transform geometry node to have the correct result. So to do this, we can take the right view, so this view here, and we can add another transform geometry. So if I link these in a transform geometry, I can press shift right and drag to create a reroute and link this output to this reroute. And now here we need to translate this object on the X and on the Y because we want this object here. But as you can see, the correct point is what? Is this point here, okay? So the X and Y component of the bounding box of the original collection of assets. So again, we have here the bounding box of the original collection. So we are able to access to the minimum and maximum values here. We can calculate the vector between the minimum and the maximum, okay? Separate this vector from the maximum and minimum to have the three components, so the X, the Y, and the Z component, and we can only use the X and the Y to offset the 2D projection. Why these two axes? Because now the origin point of all the three 2D projections is starting from here, okay? And so we need to take this X and the Y, use these components in a new vector, and use it in the translation of this 2D projection. And to do this, we can take the maximum of the collection of the assets, subtract what? The minimum to get this vector here. We can take this bounding box and move it outside this frame, and to move outside this frame you need to press Alt and P to unparent these, and you can see the same command here in the node, remove from frame, Alt P, and now I can drag outside the frame and move these up a little bit, make two reroute like this, and now I can separate this vector in the X, Y, and Z. I can move all these nodes a little bit. I can add a combine X, Y, Z, and what we need is to take the X, the Y, leaving 0 on the Z, and I can link these in the translation of this geometry, and the result is exactly what we want. So now the position of the 2D projection is correct. I can drop this root with the Ctrl X and not X, because if you press X you delete not only the reroute but also all the connections in the input and the output of this node. So press Ctrl Z to undo and press Ctrl X to dissolve the node. Now we need to do the same for the 2D projection of the front view. So this view, this was the right and this is the front, and for this reason I can take this combine XYZ and transform geometry, press Shift and D, and I can press Shift right drag to make a reroute and move this after this transform geometry, link this output in the transform geometry and this output in the reroute. And we need to manage this combine XYZ, linking what? We only need to move the 2D projection on the Y-axis and not on the X, because as you can see, if I press Shift Ctrl and click, this is the initial position and we want to move these in only this position to make the final 2D projection. So I can use only the Y-axis and voila, this is the result. We can maintain in the same position the 2D projection on the Z-axis, that is this, and we don't need to move it, and we can press Shift right drag to make a reroute and move this a little bit. Now we can connect the output from this index switch, and this is the result from the top view. So as you can see, we have all these views, only the right, only the front, only the top. But if we want more control in our export, maybe in a CAD format or whatever, it would be useful if we would add a new parameter to have an offset between these 2D projections and these 2D projections, so a sort of space between these 2D projections. So we can go in the group input and go here after the menu that we can call views, because this is the view we want to have in the result, and add another parameter. We can call this views space. The type of this is a float and the subtype is a distance, because maybe we are working in a real environment, so we are using a real unit measure in our project, so we need to maintain the same logic, and we can set the minimum of 0 and single value like this. And what we need is to use the same view space in addition to the offset we used before to place our 2D projections. So here, between these separate x, y, and z and the combined x, y, z, we need to add the group input and use this view space and add this result with the x and link this result in the x, and the same for the y, because we want the same distance on the x and on the y axis of these 2D projections. So the gap needs to be the same, and we can use this view space here, linking the y component before going inside the combine x, y, and z, and the same result of the y we can link this in the combine x, y, z for the 2D projection of the front view. And now if I collapse with h these nodes and increase this view space, as you can see, we have a correct gap between all these 3 projections, okay? And we have more control of our setup and result. So this is the final part about the offsetting of these views. And now we can select all these nodes, press Ctrl J, F2, and call it views choice. Now, because we want to export this result in a CAD format, for example, the DXF format, we need to clean these lines, because if I press Shift and Z, you can see we have all the meshes and the faces projected on the X and Y plane. So we need to delete the faces and merge the vertices. So from this output, we can add a merge by distance geometry. We can leave 1 millimeter, so keep in mind it depends on the type of your project and the scale you are using in your project. So I will leave this 1 millimeter, and then we need to delete the geometry, and in detail I need to delete all the faces and selecting the domain of faces. In this way I can only have these clean lines. I can select all these nodes, press Ctrl J, F2, clean lines. Now maybe you want to have a different origin position for all the 3D projections. So imagine you want to have these assets in a different position in the 3D space. You don't want to have the top 2D projection under the original collection of assets, but you want to separate this origin and move it in another point of the viewport. To do this, we need to take all the system we have in the result and offset starting from the origin point, for example, the global origin point. In this way, I can create a camera, for example, looking this part of the X and Y plane, and I'm sure to have the result always in the same position, even if I take the assets objects and I move them in another point of the viewport. So in this case, I could move these elements here, and if I have a camera looking in this part of the viewport, I lose all the information of the 2D projection. So if I want to maintain this projection here, we can select our 2D projection system and reset the origin. Reset the origin, what does it mean? It means to calculate the minimum of the bounding box of our collection of assets, so this point as described before, and this point is represented by this vector line, and what we need is to take this vector and offset all these results by the negative of this vector. So we need to sum the negative scale of this vector, or subtract this vector, is the same. So if we want to add another parameter, we can add a new input here, is the reset origin, and the type is a boolean, and we can set a single value and add a group input. And now if the reset origin linking to a switch is true, we want to reset the origin of all this 2D projection system. Otherwise, we want to maintain the same result we have now. So I can link with the Shift Alt and click the output, and this is the same result. And if I select this reset origin, I have no geometry because in the true condition I have no input. So now what we need is to take the original realized instances, so this point here, and recalculate the bounding box. And to do this we can select this line, link these to a reroute, press Alt and P to be able to move this out from the frame, link these in another reroute in this zone, reroute like this. We can drag in a bounding box to have the minimum point here, and now we can use another transform geometry to offset what? This geometry by what? By the vector position of the minimum of the bounding box scaled by -1. Why -1? Because this is the direction of this vector, okay, the position of the minimum. We want the opposite, and we want to add the opposite vector on our geometry to offset all in the same direction. And if I link these, as you can see, now we have all the system starting from the global origin point of 0. And even if I take all the assets objects, select objects of the asset, if I move these around the 3D space, I have the result of the 2D projections always in the same starting position. Now we can select all these nodes, press Ctrl J F2, reset origin. Do you want more control? Okay, we can add another input, and this is a vector, and in the tail this is the origin offset, and we can select the type vector, the subtype with the translation to have here the label of x, y and z from a minimum of 0 single value, and we can add a group input another time and use another transform geometry to be able to have another offset. Why? We will discover it next, because maybe in your final result you want to take all these 2D projections and have a little margin from the external border of the paper if you want to print this result on an image or whatever. So if you want to have it, you can use this origin offset. We can use it and link this origin offset in this translation. Select all these nodes, Ctrl J F2, origin offset. And now if I increase the X or the Y, we have the correct position. Unfortunately, we cannot isolate the selection only for the X and Y as a UV map, for example. So I suggest you to not use the Z, because next we are going to add some levels to be able to see all the lines and the colors and the background of the final mesh if we want to have a different result. So not a pure lines to export in a 3D CAD format, but maybe if you want to print something or have a render. So please leave this 0 on the Z-axis always. Now from this moment we could be able to export this selection using the menu File, Export, and if you don't see the item Autodesk DXF format inside this menu, you can enable the add-on inside the Edit, Preferences, go to the Get Extensions tab, search AutoCAD, and you will find the two extensions Import AutoCAD DXF format and the Export AutoCAD DXF format. You can install them, and next you will be able to see the item inside this export menu. As you can see now, I just installed it and this is the result, AutoCAD DXF item. I'm not going to discuss all the elements of the parameters in the export window, but I suggest you to select in the export the top view projection and only select the check to export only the 2D projection we have here as the result of the geometry node setup. Feel free to play with the other parameters. Now let's jump to the second part of this tutorial, so the making of the styles of these 2D projections. Why this? Because maybe you don't want to export in a 3D CAD file, but you want to have a stylized result with the background, with colors and a color for each element of the assets, or a unique color for the entire group of lines. thickness, etc. So to do this, I thought this concept. So imagine if you want to colorize the lines of each projected asset with a different color. And to do this, I thought a group of collection, and each collection has a group of meshes, and each mesh has two parameters, one for the color and one for the thickness. And then my element of the asset, in this case this main column 1, main column 2, etc., will have a little geometry node set up to select the index of the color and thickness I want to set on that element. And inside my 2D projection, I'm going to add a new collection of the styles I want to use for my 2D projections output. So I repeat this concept. I have all the assets in my collection. I projected all the assets on this plane, X and Y, but because this projection depends from the original meshes inside these assets, I can use my 2D projection, select a new collection of colors and styles I want to use. Each collection of styles may have more than one color and thickness, and for each element of my assets, I'm going to add a new little geometry node setup to decide what is the index of this collection of styles. So maybe this item will have the red color and 0.1 millimeter for the thickness of the lines, and the second item will have blue color and 5 millimeters for the thickness. And in this way, all the information of the elements of my assets will be used on the projected lines in the 2D X and Y plane. So let's make these collection styles. So I'm going to select this collection, right the button, new, and we are going to call these in 2D projection style 1. Inside this collection, I'm going to select Shift A and add a simple plane. You can add whatever geometry you want, and I rename it in 0 underscore red, for example. I can duplicate it and rename it in 1 underscore blue, and I'm going to make a third element with a Shift D and rename it in 2 underscore green. Now we need to go in the 2D projection and add in this group output a new panel dedicated for the styles. Inside we need to have an input, a boolean input to enable it. If you want or if you don't want this stylized output, is a boolean single value, and we need to add another input to select the collection of the styles, and this type is a collection, and we can select the 2D projection style 1 and we can enable it for now. Okay, now we can define some styles going on this 0 red plane. Add a new modifier, geometry nodes, press new, and what we want is to add 2 parameters. You can add whatever parameters you want, but I think the color and the thickness is the base for this purpose. So we can add a new input as a color. We can rename it in color, single value. We can add another input, call it thickness. Here I'm going to leave the subtype to known, not choosing the distance, but you are free to select the distance if you want to manage these in a unit measure from a minimum to infinite. This is a single value, and these are the 2 elements, and I can rename this geometry node set up in style 2D projection, and the goal is to save the information of the color and the thickness for this element inside these elements, because I want to take the attributes stored inside these elements from my 2D projection system, okay, this object, because we have a plane and the plane is a geometry with 4 vertices. I want to manipulate this object as if it was a single object and not a group of vertices. So I want to convert this plane in a single instance and save the color and thickness inside this single instance. And in this way, I can have in this output a unique object, an entire unique object as an instance and not a mesh. And you will better understand why I'm going to convert this geometry in an instance inside our 2D projection system object here. So I select this red, I convert this geometry to instance to have only one instance. Inside I don't care what there is. And next I'm going to use the store name attribute. The type of the information is the color and the domain is the instance because we have now one instance from this output. I won't rename it in projection underscore color and link the color. And I want to duplicate this another time, selecting here the float value of the thickness, and we can set thickness, thick, and link this thickness. In this way, I can have these two attributes stored inside of this instance, and we are able to get it from our 2D projection. So in this case, I'm going to select a red color like this, and a thickness of 0.02, for example. I'm going to select the blue object. I'm going to add a modifier and style 2D projection, and here I'm going to select blue and a different thickness, 0.05, for example, and the same for the green. Add unsigned style 2D projection, 1 on the green and 0.01 for the thickness. Now the 2D projection style 1 is ready to use. Now what I need is to go inside my assets, and for the elements I want to colorize, I need to add a little geometry nodes to set what index I want to use of this 2D projection style, if I want to have the red, the blue or the green. Now I cannot select it by name, but I can select the index of the element inside this collection. In this case I used this indexed value to be able to see in a more practical way the order of these elements, but you can reorder as you want and rename them as you want. So the idea is to select my main column of my structure, and as you can see is this column here, and this is projected here for the top, here for the front, and here for the right view. And now I'm going to select it, adding a new modifier, and I'm going to add a new geometry nodes, and I'm going to rename this geometry node in assign style, and inside this little setup I'm going to add a new input here, and this is the style index. This is an integer value because we have integer indexes from 0 inside our collection. This is a single value, and what we need is to save this information inside our original mesh. And to do this we can use the store name attribute and save this information inside the point of all these vertices of the mesh, because all these points are going to be projected on this plane, and because we are going to use the mesh to curve to inherit this information and next reuse the curve to mesh using a profile to be able to create the mesh of this projection, we need to save this style index for all the points of our geometry, okay, to maintain the same color, the same thickness and the same style for all the curves that describe our mesh in the 2D projection. So we can set here the integer, link this connection of the style index, set here the style index name. As you can see, we have 0 for all the points also in the spreadsheet, and maybe I want to set, for example, the style with index 1, so blue, okay, the blue index, the second element of my 2D projection style 1 collection, okay, for my first main column. And now inside my 2D projection, what we need to get the correct color and thickness information by the index, the style index set inside my main column element, we need to move this up a little bit, this part a little bit, because the idea is to take the output of this index switch. We don't have to pass inside these two nodes and use these to colorize the lines. Absolutely not. We need to do the raw information about these projections, and from these we can use the mesh to curve node. And if I press Ctrl Shift and click, as you can see, we have a free conversion of all the meshes with the faces to a curve system. And if I select the control point inside my spreadsheet, as you can see, we have the style index inherited from the vertices of our meshes of our assets, and this is because at least one of the elements has this attribute, so Blender is able to automatically make the same attributes and set a default value, in this case 0. And if I go somewhere inside this list, you can see these 1, 1, 1, 1, okay? These 1 values are the exact value of the index we set in our main column 1 element. So if I turn on the pin on this 2D projection and select our column, as you can see, if I set 2, we have 2 inside this style index. If I set 1, we have 1. And with this attribute, we can read and get the information from the collection of the styles we set in our geometry node setup. So here in this collection, so the element 1 will be these, the element 2 will be these, or the element 0 will be this instance of this collection. So to do this, we need to add here a group input, and inside this group input we have the collection of the styles we set here to the projection style 1, and from this we can link a collection info node. We need to realize these instances, but keep in mind this very important thing. When you use a collection info node, you always have from this output instances, not meshes or whatever, instances. So a free way to output what you have in this collection input, but in the output. And this making of the instances is an automatic operation by this node. So in this case, what we have, if we don't turn it on, these separate children, is only one entire instance that contains our 3 objects of the collection. So first of all, we need to separate the children, okay? So separate this output, getting what? 3 distinct instances that contain inside the instance output we made for each element of this 2D projection style, and no longer the mesh, remember, no longer the plane, the original plane with vertices, but the instance. And from this output now we have this situation. So 3 free instances made by the collection info. Each instance contains the output of each element of the collection that is no longer the mesh, but we transformed them in a geometry instance. And so what we have is an instance inside an instance, but with a difference. The instance inside this macro instance made by the collection info has the color and the thickness information we need to get. So to open this box and let this instance be free and readable, we need to use the realized instances node, but without using this realized all, because this realized all realize all the levels of nested instances from the top to the bottom structure of the elements. So leaving this realized all, I would open the first box to get this instance, and next open another time this instance to get the original mesh of the plane with vertices, etc. And we don't want this result because I want to get the correct index of this instance okay, the inner instance with the integer 0, 1 or 2, and selecting the correct inner instance, we want to get the attribute of the color and the thickness. So to do this, we need to open the box, okay, this instance made by the collection info only one time. And to do this, we need to turn off this realized all and use this depth of 1. So please, Blender, open the box only one time to have the ability to read the information of the instances itself. Instances made by the output of the little geometry node we added before on each of these elements. It could be harder to understand, but if you repeat this part of the video, I'm sure you will fully understand this concept. Now that we have here in this output the 3 indexes, we need to select only what we need. And what we need is defined by the mesh curve attribute we saw before. So this style index we have in the control points of our curves. So what we need is to use the store name attribute 2 times, one for the color and one for the thickness. So one is going to be the color for each point, and the second the float for each point, and one will be the same as we named before. So projection color, and here the projection thickness. And remember, this is the same name we used inside our 3 elements, but you can use a different name if you want here, because we are going to take this information and use in the next part of the 2D projection workflow. So what we need now is to read the attribute of the style index per control point, okay, and use what the sample index node to select the correct instance on which we want to get the color and the thickness attribute. So we can link our 3 instances of our collection and get what the color information in a domain of instance, because here we have the 3 instances as the output, and I want to get the attribute called project call, that is a color attribute. We want to get this information from this index of instance and link this inside our store name attribute. So this schema means that we have the curve. For each point of the curve, we want to save the color information called project call. But to do this, the system is going to go back in this workflow and take for each control point the attribute of the style index we saw here in this attribute, and with this attribute is going to select the correct instance from this group of instances, and after selecting the correct instance by this index is going to get the attribute of the project color, and it will save this information inside the control point and in detail in the same name we set here. The same for the thickness. So the idea is to select these 2 nodes, press Shift and D to duplicate them, and instead of using the color we need to use the float and rename these in thickness, because we want to get the attribute of the thickness from what? From the same group of instances and the same index of instance, and link this value here. Now we can select these nodes and make a new frame. So I can select these, Ctrl J F2, getting style settings. Now if I want to see the result of these settings, we need to take this output, so the output of the curves we have here in the viewport, and convert these curves in a mesh. And for this purpose we can easily use the curve to mesh node using a simple curve line as the profile, and I'm going to set minus 1000 and 1000 on the x-axis for the profile. So if I press Ctrl Shift and click, you can see the line in the viewport. The Z is wrong, I need to set 0, so the line start from here to here, and Blender is going to use the y-axis to create the profile along the path of the curve, making the final mesh. So I can link these in the profile curve, press Ctrl Shift and click, and this is the result of the conversion. It's too much, I know. And to manage the width of this profile, we can use the radius, because this profile curve uses the radius of each control point of these curves. So I can use the set curve radius here, and as you can see, if I change all the radius of the curves, the profile changes, and we need to link something inside the radius. So the result of this store name attribute. So I can press F3 and press read name attribute and link directly this attribute and take the project thickness inside this radius. And as you can see, we can already see the difference between this part of this curve and the other curves of the 2D projection. Now I'm going to rename the panel of the styles in lines style, because this worth only for the lines and is not going to work with the portals, next feature we are going to make. So for now I want to add two more features about the thickness, and for this reason I'm going to add a new input here that I call thickness and percentage. So what I want is to have a new parameter to increase or decrease all the values of the thickness from this output using this percentage, this global percentage, to proportionally increase or decrease these values. So I'm going to add the group input, and this thickness in percentage is a percentage default to 1100, minimum 0 and a single value. And this is not a float but an integer number, subtype to percentage, default value 100 and minimum 0. So the starting value will always be 100 in your new setup, and in this way I can use this thickness. And remember, you need to multiply this value by 0.01, so divided by 100 to have the correct conversion number from this input attribute in the correct units and scale inside the geometry nodes. So we need to multiply this value by 0.01 or divide it by 100, it's the same, and then multiply our thickness by this result before linking this result in the radius. In this way, if I set 200, you can see I double the thickness values of my curves. And not only this, I want to add another feature, adding a new input. This is the thickness override. That is a Boolean attribute, single value, and add another input. In this case, I want to maintain the thickness as a float and from a minimum of 0, because I want to use this Boolean to override all the thickness set in the curves to have a single thickness for all the curves, even if I don't set any style index inside my assets. In this case, I need to set here a single value, and I need another group input to be able to ask if I want to use the thickness override in a switch node. And from this, I need to select float as the input and the output. So now if I want to override my thickness, I need to link directly the thickness attribute inside the true. Otherwise, I want to maintain this part of the workflow, and I can set this to the false and this output in the radius. I can press H to collapse, Ctrl H in this node to collapse the unused attribute. I can move a little bit this and press Ctrl H on this node. I can select all these nodes, Ctrl J, F2, thickness override. I'd like to see the color of these curves now, and to see them I need to use the set material node and set a new material. So we can go in the material properties, make a new material, rename it in 2D projections, go in the shading editor, and what we need is a simply attribute with the F3, so attribute, and we know that we previously saved the P projection color attribute that contains the color for each point of our curve that is inherited in an automatic way, converting these curves to a mesh. And in this way we can link this color in an emission color, leaving the strength of 1. We don't need any roughness, metallic or whatever material, so we can drop this principle and link directly this surface inside. We can go in the geometry node, and inside this set material we can set the 2D projections material. We can enable the preview of the material, and this is the final result. As you can see, we have, it's obvious, an overlapping of the thickness of these curves, but you can see the correct selected style index inside our components. So in the 2D projection style 1, we have all the lines that use the index 0. And why the index 0? Because if you don't set another style index inside the component, so if I take the main column 2, for example, where there isn't the geometry node to select the correct style index of the collection of styles, the system will set in this control point the style index 0, so a default value, because Blender needs to set a default value if you don't set your own value. And the parameters of the index 0 inside our 2D projection style collection are these: a red color and a thickness of 0.02. Maybe you want to use a different default value, so the black color, for example, to the default color, so I can set 0, and in this way all the curves I don't use to set a specific style index will use the index 0, so the black color. And as you can see, we have the main column 1 that is using the index 0, and if I want to switch one different style in this collection, I can easily change the index number here, 1, 0, 1, 2, etc. And inside the green style I can increase or decrease the thickness of my curves. I can press 7 to see the entire workflow, and this is the final result. Now it's obvious, in the black I suggest you to use a very low number for the thickness to have a better quality between the corner of each curve in the final projection, print and final rendering. Or maybe you want to increase this thickness if you want to emphasize and highlight some particular part of your 2D projection. In this case, as you can see, we have these 3 planes shown here, so I can use this selector to hide these planes, and I can select the 2D projection, and I can set the origin offset to 0, and you don't see any changes because I'm looking the result of this node inside a viewer. So instead of using this, I need to drop this node and press Shift, Alt and click to link this in the group output. But to work in a correct way, we need to shift and move this reset origin and origin offset at the end of the workflow. So after the setting of the material, I need to take these 2 frames and move these here, and now I need to use a switch to be able to select the pure lines, so no conversion on the mesh, but pure vertices and mesh to export in a CAD format, for example, or the result of the conversion in meshes with the faces and colors and thickness. So to do this, we can add the group input and ask if we have the line styles enabled, and if we have these enabled, I want the result of the output of this set material. Otherwise, we want to have the result of the pure lines, okay, the pure clean lines here. And now I can use the output of this switch inside this switch to use this frame, the reset origin, and next the origin offset. And now I can link this entire result in the group output, and as you can see, we have the correct shifting and offset starting from the global origin point of the 3D view in a correct way. We need also connect not this one inside this transform geometry, but the output of this switch inside this transform geometry, and now is correct. We can drop this reroute, we selecting it and pressing Ctrl X. We can create a new reroute here and move it here. press H in this bounding box, and now you can see the result of this thickness, the black color for the default style and the green for only this component in my assets collection. In addition, we can manage a color override for the line styles. So if we want to have a default color for all the curves without using any of these styles, and to do this we can select the thickness override, click here and duplicate the item, moving this under the thickness and rename it in color override, add a new input, and in this case we need to have a color socket, and we can rename it in color is a single value, and we can add a group input before converting the curves into a mesh, and we can ask if we want to override the color with a switch node. And if we want to override the color, what we need is to store the attribute another time, linking the geometry, and inside the color information of the projection call of all the control points, we want to override the color with this value. Otherwise, we want to maintain the original geometry. We can click H to collapse and use this output in the curve to mesh. Select this node, Ctrl J to hide the unused node. We can select all these nodes, Ctrl J F2, color override. We can test it. So if I press color override and select another color like pure green, as you can see, we override all the curves with this default color. If I set these to off and change the color, nothing happens. Now, before diving into the portal feature, we can add another feature here, so a custom background under these curves results. And to do this, we need another panel here in the group output, in the group input. So I'm going to add another panel, calling it background, add an input inside to enable this feature. This is a Boolean type, single value, and I need another parameter, so an input that is the color of the background, and type is obviously a color. Also, this is a single value, and a final parameter that is the margin I want to have around the meshes I have now in this 2D projection. And in the meantime, I will set the color override to a pure white to see these lines in a better way. Okay, perfect. I want to have a margin around, and this background is useful if you want to add some color behind, like a blueprint you saw in the intro, or if you want to have a particular color in the background. Also, in this case, the margin needs to be a distance to be able to have a better control of this value, like the origin offset X, Y, and Z. And we need to go inside this part of the workflow, so between the curve to mesh and the set material node. And in this case, we need to move all these nodes a little bit, like these, and we can press Ctrl H to this enabled feature of the line styles, and at the same time we could select these nodes, press Ctrl J F2, enable lines styles. Now we need to have another group input to be able to enable or disable this feature, and link this last enable that is in the panel of the background, link this in the switch, press Ctrl H, and if we don't want to use this background, we can leave the original geometry output from this curve to mesh and link this output inside the set material. Otherwise, what we want is to use this geometry inside a join geometry to join the background together and link this output in the true condition. So we need to link something here in the join geometry. The idea of the background is simple. So imagine you have this result of the 2D projection. What we need is to calculate the bounding box of the entire result of the 2D projection, make a grid with the same size of this bounding box, add the margin multiplied by 2, because the margin needs to be placed on the right, on the left, on the top, and on the bottom of this result. So we need to multiply this value by 2, and I forgot to select this margin and set this to single value. And then we need to shift the background part correctly. So first of all, we can create here the bounding box, calculate the difference between the max and the minimum to have the size of this bounding box, so this length and this length on the x and on the y. And next we need to separate this vector in the three components and make a new grid with only two vertices for the x and two for the y, and the result is this, okay, this little plane. And now I'm going to set the x and the y, as you can see here. As described before, we need to add to this x and y the value of the margin multiplied by 2. So we need to add a new group input and get the margin and multiply this value by 2 before adding this value on the x and on the y. So we can move this a little bit and drag this node in an add mathematical node, add the margin here and duplicate this add to link the y component and add the same margin multiplied by 2, press H to collapse these two nodes and link this output of the y inside the size of the y. And now to see this result, I need to link this grid inside this join geometry, draw this viewer, and in this way you can see the result of the curves. And if I enable the background, you can see this rectangular here. And if I increase the margin, you can see the increasing of the size of this rectangle. But there is a problem. As you can see, the position of this rectangle is apparently wrong, but actually this is following these rules. So the reset origin and the origin offset. So as you can see, we have the check in the reset origin, and this is the result. Why? Because the shifting I used for the 2D projection was captured from the vector of the origin of my collection, and I shifted all by the opposite direction of this vector here, okay? And the system now is using the same logic to move the center of the rectangle by the same adding vector. And this is why I see the center of the rectangle not here in the global origin point, but shifted by the same amount of length and direction. So to fix this problem, I need to shift the entire rectangle before going inside this reset origin frame and origin offset, moving this point, moving this position in the same position of the 2D projection components. In this way, they can be moved in the same position next in the workflow. So to do this, we need to take the minimum of this rectangle and shift by the difference between the position of the minimum of the 2D projection and itself. So to better understand this thought, I'm going to remove the annotation layer and I turn off the reset origin and move a little bit this offset. And as you can see, the rectangle is following the same position of the 2D projections, but with the offset of the vector between the minimum of the collection of assets and the origin point. Okay, so this vector, and this is the same offset we have from the minimum of the 2D projection and the center of the rectangle. What we need is to take this center and move in a way to align what this point, if we have the margin of 0, and this point, to have all these two objects aligned perfectly. Now, to get this offset here, we need to get two important information: the minimum position of the bounding box of the rectangle and the minimum position of the bounding box of our 2D projection. And as you can see, we have three vectors, and the red vector is the result of the minimum vector position of the 2D projection, subtract the minimum vector position of the rectangle. In this way, if I go here, where I have the curve to mesh, so the output of my 2D projection, I have here the bounding box, I have the minimum here. So what I need is to take the bounding box of this grid and subtract from this minimum that I link in a reroute for a moment, and another time here, what we need is to subtract from this minimum the minimum of the rectangle. In this way I have here the red vector, and now I can transform the geometry of my grid by this amount. So I can use the transform geometry, link this vector in the translation, and link this in the join geometry, and drop this connection. Now I need to link obviously the grid inside this transform geometry, and as you can see, we aligned perfectly in this point the rectangle and the 2D projection. But there is a problem. If I increase the margin, you can see the increasing of the gap only above and on the right. So we need to subtract a value of the margin in this way and in this way to have always the aligned center between the rectangle and the 2D projection mesh. So what we can do is to take the margin and multiply it by -1, because I'm going to add this value on my rectangle, and because I want to add, I need to multiply this positive value by -1. And then I'm going to link this result in an add node. I'm going to move a little bit this entire workflow to see better the setup. Now what we need is a combine X, Y, Z. Link this vector here in the add, press H to collapse, press H to collapse also here, and H in this bounding box, and link this add in the translation, and link the multiplication of the margin on the X, on the Y, and as you can see now, if I select my result, I have the gap exactly equal to the margin on the negative direction of the X and in the negative direction of the Y to perfectly align the rectangle with my 2D projections. Now, as you can see, if I enable the preview of the colors, you can see a bad result. So I lost the colors of the curves unless you have a different 3D point of view, but I want to see them from the top orthographic view. And to do this, we can easily shift a little bit in the negative z-axis the background, and this is a static and constant value. Okay, as you can see, we have no parameters to add inside our group input, and in this way I'm sure to be able to see always the curves above the background color. And I can set, for example, a blue color here like this, and we needed to add and override this color inside the background, and we need to set this color inside the background object. So I can press H to this bounding box, and I can easily add here after the transform geometry a store name attribute, because we can use the same parameter we used for the curves to mesh, the project color attribute, to assign a particular color to all these 4 vertices of the background, as we saw for the meshes of the 2D projection lines. Now we can add the group input another time, and we can get the last color attribute and link these to the value, but the type is wrong. So keep in mind, we need to select not the floor but the color, and as you can see, we have the blueprint of our structure. We can select this node, press Ctrl H to collapse the unused attribute, the same for this node, and now we can select all these nodes and also these nodes, press Ctrl J, F2, background, and now we can use these margin values to increase or decrease our margin, change the color as we need, enable or disable the entire feature. This was the second part of the tutorial. The last part is the making of the portals view. So we are going to create on these results, so you are going to be able to have 2 features, one above the other, so the colored lines and the result of the portals view using the cycles engine, obviously. Sorry for my head, but this is the result of the margin if I increase or decrease the value or change the color as you need. Enable or disable the feature of the background. Now let's dive into the portal feature, and to do this I'm going to close these 2 panels to be able to reshift my face in the correct position of the video. And now I'm going to add another panel inside my group output called portals. In this case, I'm not going to make a check for enable this feature because I want to add a generic menu switch here in the group input. So I'm going to add here below the sources an input called type, and this will be a menu as a single value. And now inside my workflow, I'm going to add exactly here before the reset origin the selection of the type of output I want to have in this workflow. So if I want to have the pure lines, the portal features, or both of them. So to do this, I need to add a menu switch, and I can add a group input to link the correct menu switch in the correct type. In this case, I'm going to select the node, set here lines, portals, or both, like this, and I'm going to link the output of this menu switch in the rest of my workflow. So in this case, I need to go in the group section, select the type, and here in the default value for the menu, if you drag and drop or open your 2D projection system, I'm going to select the lines as the default value, and same here in this socket, and the result is this. I want the original lines. If I select the lines, I want a different result here in the portals input, or I want the join geometry between the lines and the result of the portals here in the both input. I select this node, press Ctrl H to collapse, and move here. Now, the idea behind the making of these portals is to create 3 planes, 3 grid from the geometry node setup. So one on the top, one in the front, and one on the right, looking inside our original collection of assets and elements. And this type of looking is very important because we are going to use the direction of looking for each of these plane to capture the correct pixels and the shading result of the scene. And with these parameters, so the position of the vertices of these planes and the direction of the looking, next we'll be able to move, shift, and offset these 3 planes where we want inside the 3D space, in our case in the same location of this 2D projection on the X and Y plane, and see the result of the shader of our elements. Maybe you are not so familiar with the portals node in the shading editor, so I'm going to try to explain it as best as I can. So first of all, we need to make the 3 grid, one for each view. So we can start to make this grid here on the right view, and to do this we need to add a simple grid with 2 by 2 vertices. We need to set the sizes depending on the information of the bounding box of the original collection, and the original collection is here in this part of the starting of the workflow. So the starting point, the realized instances, because you cannot calculate the bounding box of an instance, but you can calculate the bounding box of a mesh. We could use the same bounding box here, but I prefer to leave it inside this point to better divide this workflow. And I'm going to link these realized instance in a new reroute node, drag this again, and calculate the bounding box of our collection of objects. I'm going to move this grid here because the setup will be pretty big. Now we need to calculate the subtraction between the maximum and the minimum of this bounding box to get the entire vector between this point and this point, the minimum and the maximum. And then we can separate these 3 components to have all the sizes of this bounding box, and we can link the y in the x and the z in the y of this grid. And now if I press Ctrl Shift and click, you can see this rectangle that has the same sizes of this part of the workflow. Now we need to transform and rotate this geometry to be able to align in this part of the collection. And to do this, we can rotate on the X by 90 degrees and then on the Z by 90 degrees, and the rotation is done. As you remember from the other parts of the workflow, if you want to move this object in this point, what we can do is to take this object, move this object from the minimum position here in this point, and then add the X value of the bounding box of the collection of the assets. In this way, we can move this point here and then add the X value of the bounding box, and we will get the correct position of the grid. As I remember you, if you want to move this object here, you only need to take this object and transform by the difference between the destination point subtract the source point. And I repeat this, you have this vector position, you have this vector position in the 3D space, and the difference between this vector and this vector is this vector, okay, is this vector. So in this way I can add this difference to this point or this entire object, and I will shift the entire object in this point. I could use directly the translation of this transform geometry, but I prefer to divide this problem into problems. So here we have the transform geometry, and as I said, we need to take the position of the minimum of the bounding box, and we have this information here in the minimum of the bounding box. Use this and subtract what? The minimum of the bounding box of this rectangle. So if I take these and calculate the bounding box, I can subtract these two vectors, getting this result, and now I can add these in this way, and you can see the shifting of the rectangle in this position. Now from this position I can add another vector, and I can link here a combine XYZ and link what? Only the X component of the bounding box, of the size of this bounding box. So I can select the X value of this separate node and link these on the X, and as you can see we aligned perfectly this rectangle here. And because I'm going to use these three nodes also for the front and the top portal, I shifted these a little bit here, and I make a reroute for this subtraction, and I want to add a little thing about this position, because as you can see we have an overlapped result of the meshes, and because the portal is the projection of the point of view starting from each point of this single face through the internal part of this bounding box, I want to leave a little gap here in between, otherwise I could have not the correct colorized face of this column, but the value of black, so non-color. So to have a perfect result, I'm going to add on this X value a little numeric value, so 0.001 before linking these here to not have any overlapped issue. Now a feature I want to add to this face is the ability to go inside this bounding box to have the good cut sections for the result of the portal. So to see through this entire bounding box, I need to shift this object along the negative x-axis. So for this reason, inside the portals panel of the group input, I'm going to add three values. So the offset right, a type of float, and the subtype of distance from 0, and this is a single value. And I'm going to duplicate this element also for the offset of the front, and duplicate another time for the offset for the top portal. And the idea is to get the group input to have these three offset values, and if the offset right is greater than 0, so I set here a value, I want to add this value on the already set X value here in the transform geometry of this mesh. So in this way I can ask if this is true. I want a float value, and this value will be the offset right multiplied by -1, linking this value here in the true. Why? Because I'm going to link this output here in the add mathematical operation here. So I need to shift the rectangle through the negative x-axis. So here I'm going to set a positive number, but in this setup I'm going to subtract this number. And if this is false, I need to set 0.001 as I set here before to maintain the correct not overlapped feature. So I can close this a little bit, press Ctrl H to collapse these, and I can move this a little bit. I can adjust these nodes a little bit, moving these here, moving these here, moving these down, pressing Alt and S to switch these two elements, moving these three nodes down a little bit of the setup, and press Ctrl Shift D to duplicate it, because we need to calculate the same result but for the y-axis, so the front view, this part of the view. So you can see these particular lines. What we need is to have the correct lines linked from the output of the correct view, and this was the right view, this is the front view. So I need to link this output inside what? This particular node here for this portal, and I'm going to make a reroute like this for now. And now the difference between the right and the front is that the size of the grid is wrong in this moment. So if I press Ctrl Shift and click, we can debug the steps of this setup, and now the information about the sizes needs to be different. So I need to link not the y on the size x, but the x-axis inside the x, because I want the same width as the bounding box of my collection of assets, leaving the same z for the y. Now let's take a look to the rotation. If I press Ctrl Shift here, I have the wrong rotation because I want to maintain the correct rotation for this point of view, and for this reason I can easily reset 0 for the z and leave only the x-axis in 90 degrees. Next, the next transformation is the alignment of this rectangle, where not here in this point but in this point. And what we need is to take the minimum of the bounding box of my original collection of assets, so I can link this minimum here and make a little reroute to see better this link like this, and subtract from this vector the minimum of my bounding box, so the minimum of this object. And in this way, if I mute for a moment this add, you can see the correct alignment in this point as described before. And now we only need to add what? The correct offset of the front view and not the right view, if it is greater than 0, otherwise a value but not on the x but on the y-axis, because I want to add a little gap where in the negative direction of the y-axis. So we need to link this connection here first of all, and drop this connection. Why? Because this connection is the adding of the entire x size of the bounding box of my collection of assets, and we don't want to add this value on our rectangular. So I will drop this node and unmute this add. Now we have the wrong value here in the false condition, because I don't want to move this rectangular in this way but in this way, in the negative direction. So I want to set minus 0.001. Perfect. I no longer have the overlapping between these faces, and I need to change this offset right, pressing Ctrl H, linking the offset front in these two socket and pressing Ctrl H another time. In this way, if I increase the offset front, I don't want to go outside, I want to cut the collection going inside to have the correct result of the portal. So in this way we need to drop this multiplication, because the direction is the positive y-axis, in this way. I can move this node a little bit, and now if I increase this offset I have the correct shifting inside this collection of assets. Next we want to save the position. Okay, it's correct, as you can see here. Next we want to save the direction that is wrong in this moment, because the looking I want to have from this rectangle is the positive y-axis, so this direction. So I need to set not -1 here but 1 in the y-axis for this direction attribute. Next we need to transform and rotate again this to have the correct 2D projection of this portal on the x and y plane, and to do this we can start with 0 values here, press Ctrl Shift to see this result, and rotate by 90 degrees. Next we need to realign this object in this plane following the minimum position of the 2D projection of the front view. So I'm going to select the front, perfect, and to do this we already linked the correct output from this view choice inside our part of the graph, and if I press Ctrl Shift and click you can see the correct alignment of our portal on the 2D projection. And if I increase the view space, all is correct. I can't use the reset origin and the offset because they are at the end of the graph, and because I'm looking this result from the viewer I can enable or disable, and I can see the result in this moment. Now I can link the result of the front view in one index of this index switch, and we need to do the same for the last view, so the top view. Ctrl Shift D and move this a little bit. Okay, for the same reason we need to link the correct output of the view we have here in this output. So we need to take the top view, the result of the 2D projection of the top view, and link these to the final part of this graph to offset our portals in the correct position. And now we need to take the correct sizes, so I can move these a little bit, and if I press Ctrl Shift and click we can see this result, and we can see that the X size is correct, but from the top we need to have the Y size here in the Y socket. So we need to take not the Z part but the Y part of our collection of assets and link this value in the Y, and we have the correct rectangle. Next we need to transform these, but we don't need any rotation this time because the automatic creation of the plane is already on the X and Y, so the same plane as the top view. So we can drop this node, go further on this transform geometry, so the shifting of the object were not in this position, but we need to move this up in this position. So first of all we want to align this rectangle in the minimum point of the bounding box of the collection of the assets, and this is the correct approach. But let's make the correct operation here for the selection of the offset, and we need to link not the offset front but the offset top, because we want to have the ability to go through this entire object, so we can test it. Now if I increase the top, as you can see this operation, and this is wrong for two reasons. One is because the rectangle needs to start from this point, okay, in the height, and go down. So I set for a moment 0 in the offset, and we need to add here something in the Z component because we need to go here, okay, and this value is the exact value of the height of the entire bounding box of our collection of assets, and we can get this information here. Okay, here we have the bounding box of our collection, the sizes, the separation, and we have the Z component. So we need to drag this value inside the Z, and in this way we can create a reroute like this. We can move this a little bit and make more readable this graph. Now we can test the offset top, and if I increase this we have the wrong result because we want to go down, and to go down we need to add to our value another value here, link this output here and link this to the Z, dropping the Y part because we don't need it. We need only the Z component. I can do this, dropping this reroute, and now we can test it. Is it correct? No, because I want to go down in the negative Z direction to go through my collection, and to go through my collection we need to add a negative value of the offset, and again we need to multiply this value by -1 to go to the other side. And now if I increase this I go down, but if I set 0 I have the false condition, and if I have the false condition I want to add a little gap. In what direction? The positive Z direction to avoid the overlap. So instead of having -0.001, so 1 millimeter in this case, I want to add 0.001, a positive number, and we have the correct result here. Now that we have the correct position of the portal, we need to store the position and the direction. Now the direction, what is the direction? The direction is the negative Z-axis because we want the portal look down, okay? So we need to set not 1 in the Y but -1 in the Z direction. We don't need any transform geometry for the rotation in this case because we only need to shift this part, aligning it with the equivalent 2D projection on the same X and Y plane. So we can drop this node and we can try to see the result of this transform geometry with the shift, control and click. And as you can see, we have the correct alignment. And if I increase the view space, I don't have any change and all works. Now I can connect this result in the index of 2 related to this index switch, and now we can join all these portals together. So we can link this result and this result to have all these portals together in this output, the right, the front and the top portal. Now because in the shading editor we are going to use a different shader to see the result of our mesh in the 2D projection, we need to distinguish the shader of the 2D projection, in this case the emission of the meshes, so this result, and the result of another kind of shader dedicated for the purpose of the portal feature, and this is the ray portal BSDF. So to use these two shaders together we need to use a mix shader, and to distinguish what geometry needs to use one type of the shader or the other type of the shader, because we want to have both of these in the result. If I go in the geometry nodes and set here in the type both, we need to go in the geometry nodes and, for example, set for all the 3 portals a new stored name attribute, a boolean value, check it to true, where here in the output of this index switch. So here we can store a new attribute, and this is a boolean value for each point and always set to true. So the rest of the 2D projection meshes made by the curves converted to the mesh, etc., will have the value set to false for this attribute. And we can set here portal, the name of the variable. Now, for the same reason described for the background that we shifted by 2 millimeters in the negative Z direction to not have the overlapping issue with the result of the mesh, of the 2D projection of the mesh, we can insert in the middle the result of the portal. So we can offset by 1 only millimeter the portal meshes, and in this way we can have the result of 3 layers. The upper layer is the result of the curves converted in meshes with the profiles, the colors, the thickness, etc. The next level below will be the result of the portals, and the final layer below will be the mesh of the background. So in this case, I can go here, and after this store name attribute, we can use the transform geometry and shift by 1 millimeter in the negative z-axis the entire result of the portal. We can set the material also in this case, so we can set the 2D projection, and now that we have the entire workflow of this part of the portal, we can create a last reroute here for the top portal. Select all these nodes, press Ctrl J F2 portal right, select these nodes, Ctrl J F2 portal front, and select this last part of the setup, press Ctrl J F2 portal top. We can make another reroute for this part of the workflow, and that's it. We can select all these nodes and set views choice, and now from this output of the material we can link this output in a reroute here. So this is the final result of the portals, okay? And in the selection of the type of the results we want from this geometry setup, we can easily link the portals in the portals and the portals with the 2D projection system in this geometry node if we want both the lines and the portals. Now if I set only the portals, you can see this result here in the exact position of the lines, and if I want both and press 7, you can see the 3 levels and layers discussed before. So we have the first layer of the curves converted in meshes, next the portal, and next the background. We can make another reroute to make it more readable. We can select one of these group input, go to the select grouped by type to select all the group input nodes inside this setup, pressing Ctrl H one time and another time to clean the entire setup. This is the final setup of the geometry nodes, and now let's finish the shading part. So we can go in the shading editor, and as described before, if I set 0 for a moment here in the origin offset, if I go in the top orthographic view and see the result of this 2D projection from the front view, you can see we have half of this emission and half of the result of this ray portal BSDF. So we need a mechanism to mix these two shaders, and what we can do is to take the attribute stored before called portal as the factor to be able to have pure false or pure true inside this mix shader, letting the system colorize and choose the correct shader for the correct part of the mesh. So the curves converted in mesh and the background will use this shader, because for all these vertices you are seeing now, the value of the portal is false, and this mix shader will choose this emission shader. Otherwise, for the part about the portal, the system will choose this way, and I can prove you, because if I add a new emission shader setting here a red color, for example, linking this emission in this shader, you can see the output of the portal part, okay, the portal mesh. Now I need to define what is the ray portal BSDF and how it works, and it works in this way. For this case, we have the rectangle that originally is placed here in this part of the 3D space. We stored the attribute of the position, so I can call it, and I can call the direction information always stored inside this portal part, and the ray portal gives us in the output the result of a simulated camera, okay, simulated point of view as a camera, starting from each position through each direction. So imagine to have an infinite number of cameras, okay, one here, one here, one here, one here, one here, all these cameras pointing, as I'm looking now, the 3D viewport. left, okay? So through the y-axis. And the result of this looking is the result of the pixels stored inside the mesh itself, the faces itself of the mesh. So if I link this vector of the position in the position and this vector of the direction of the looking inside this direction and link this BSDF here, I can set here for a moment the portals type I want to see. You cannot see anything because we are using the EV engine, but we need to switch in the cycles engine and you can start to see something here. Okay, what you are looking here is the visualization and the projection of this fake infinite number of cameras from the position stored inside the mesh we rotated and shifted here in this position, looking through the direction of the axis we stored in the same mesh. Now I can take these lights and move them here inside our structure, and as you can see, the portal preview is updated in real time. Okay, so I can select my 2D projection, go inside the geometry nodes, and if I select all the object of my assets and also the lights, I can move these here, for example. And now if I select my 2D projection and go inside this type and select the lines, I have only the lines as the output, but I can use the portals and at the same time I can use both of them. Okay, and in this way, if I press 7, you can see the result of the portals plus the layer of the colored curves of my system, projection system. And this is very useful. And from now I can switch between the view. So I can switch for the right, okay, the front, the top, or all these views. So selecting only the portals and increasing a little bit the view of the space, you can see the projection in 3D for all these views using these portals. And if you didn't understand how this ray portal BSDF works, I remember the concept. The concept is, imagine you have a mesh and place an infinite number of cameras on this mesh and you want to get some light information and the shader information of the environment. You need to start from a position, the position of the camera, and then you need a second position, the position of the axis on which the camera needs to look through. And you can distribute these starting positions and the corresponding direction of looking for every face and every point of your mesh, and the system will interpolate this information, obviously. And now if I want to cut this structure going, for example, inside this collection through the positive y-axis, I just need to increase the offset of the front view, okay, this front view, and increases this front view, you can start to see black values near the columns here. And if I increase and increase and increase, you can see near 1 meter the cutting of the metal structure of this collection of assets. Okay, as you can see here, near 1 meter we have the cutting of this section, and this is the advantage of this cutting section. Now if I place, for example, a monkey inside my collection and I move this monkey inside my structure like this, you can see in real time the result of this projection. And a little brackets, I set here in the render properties the value of the performance pixel size to 2, because in this way I have no glitch while recording. And now if I go in the modifier stack, select the 2D projection and increase the front, you can see that I can cut the monkey, and I can do the same from the top. If I go down, okay, you can see the starting of the cutting of the monkey and the structure around this part of the room, and the same for the right view, like this, okay? And you can see the cutting section of the monkey now is black. Why? Because there is no light inside the object of the monkey that can be seen from the positions of my mesh shifted in this zone, looking through the positive Y direction for the front view. And now, last thing, if you want to import the entire system inside your project, you can do it in two ways. One is to open my file, select the collection of the sources, and append or link with this menu all the object or collection you need to project in the X and Y plane, or you can call this collection to the projection system, for example, right click on it and make it as asset to be able to find it in the preferences of your assets in Blender, make a new file and drag the entire collection of the asset from the asset browser. And that's it. Thank you guys for watching this video. I hope you like it and I hope you learned something new from it. If you like it, please subscribe to my channel. You can find this project from my Gumroad page, and see you to the next tutorial. Bye!